Welcome my friends, welcome to my YouTube channel. And before I proceed, I request all of you to subscribe my channel, spread it to many. So today's topic is on HVAC and very important topic for India, for Indian HVAC engineers, Indian HVAC project managers, Indian HVAC contractors. The name of the topic today is what is district cooling and what are the prospects in India. So the picture in front of you tells you everything, but let us look at one by one. Let me start with some introduction. There is a huge demand for air conditioning across the globe. And India, everybody knows, is one of the golden spot in this century across the world, where all the actions are happening. So the demand of air conditioning is increasing across the globe as well as in India. And the important challenge, since HVAC is an energy guzzler, to get the most optimum energy efficient system for HVAC, that's the challenge. Yes, we need air conditioning or HVAC, but we need to have an optimum energy efficient system for air conditioning or HVAC. So that's first part before we proceed further. The second thing is, what happened in the whole process, the cooling systems or the air conditioning has been a blind spot for a long time when it comes to the energy. Despite there's a clear impact of HVAC or AC onto the energy and the energy efficiency. So the demand is growing across the various countries in the globe. So this has been one blind spot, looking at energy as one of the important aspects today, right? Next, the DC, that is the district cooling, impact is exceeding their known advantage. And one of the advantages, obviously, the energy saving, because I'm talking about energy from the beginning, and rationalization of resources. These are two important advantages of DC. DC also provides new opportunities for urban development, for urban designs, and also gives the challenge to the architectural forms. DC is all about, the name suggests, district. So it's all about so many buildings, variety of buildings, and the need of that air conditioning is taken care by this district, the cooling district. So we have so many buildings, the need of the air conditioning is taken care by one district, and that's how the district cooling concept came in. It is not for an individual building, right? So DC promotes, as I said, new urbanism, mixed use, because it can take care of all the requirements of air conditioning. In a nutshell, DC actually promotes smart cities. DC is similar to a power generation system, where the electricity is delivered to each and every home, each and every shop, each and every road on the light through wires. Similarly, DC works. So this is one of the DC. You can have huge amount of systems placed at one place, district, and the cooling can be supplied to the needs of the individual buildings across. Right? So as I said, it's a plant, you can see it's a district, and there are various buildings across the district, and it can take care of the cooling loads or cooling demands of this building by having one centralized system. It says DC is a centralized cooling system which provides chilled water to the air conditioning system of user building for the cooling purpose. So the air conditioning purpose is taken care. This is a center plant which is located at one place, and as I said, for the power, the cables are used here, the pipes are used to take the chilled water from that plant to the various buildings. This is, as I said, similar to power distribution in the city. So this is all about, you have center plant, you have energy transfer station that will be installed against each building. This is the plant which generates cold water. This is a distribution network, this pipe network, the pumping network, and at each building you will have an energy transfer station that will cater to the air handling units or the fan coil units of this building. These fan coil units or air handling units will then cool the entire building or wherever it is necessary. So the air conditioning is taken care by these low side equipments called air handling units, for which the chilled water is supplied through a heat exchanger generally, which is called energy transfer station, and this is how the cooling demands are taken care of. So this is in nutshell district cooling. In a schematic, again, you can have chillers, you can have pumping system. Chillers are generally connected to a cooling tower. If it is a water cooled system, the pumps for the cooling tower. Then these pumps, then we have pumps of networking, that's secondary pumps. Then each building will have its own energy transfer station that will take care of building 1, building 2, building 3, and number of buildings. And the main component which supplies the cold water is pipes. So chilled water pipes are used. Why district cooling? And you can see the picture that will give an answer. You have to have so many number of window ACs, split ACs, or you have individual air conditioning plants like this on every top, every terrace of the building. If I look at Mumbai, or this will be installed in the basement of the building, taking care of a lot of space of that building. So each, rather than having each plants, each systems for per building, you are actually consolidating and putting at one place. So all this are not required when it. Why district cooling? There are some general points. Elimination of large number of standalone equipments. As I said, each building need not have those equipments to cool their building. Reduction of space. So if you don't have equipments, obviously there is no requirement of technical rooms or what we call plant rooms inside the building. When it comes to the equipments, obviously it will create a lot of noise. So reduction in noise pollution, and all these equipments are combined into bigger equipments that takes care of air conditioning demands of the entire city, which helps in rationalization of resources, and that also helps in energy efficiency. So both goals of energy efficiency and rationalization of resources are taken care of. That's why district cooling. And when I talk about both here, when I talk about sustainability, environment, socioculture, economic, all these parameters are well taken care by district cooling. Let us look at now the stakeholder wise, what they get, what are the benefits, why district cooling for end users. The first important aspect is comfort. So comfort is the ultimate goal of air conditioning system. DC can keep people more comfortable because of the industrial grade equipment is used, and that will provide a consistent high quality source of cooling. Because when you install a high grade industrial type of machines, they're going to produce better quality, better efficiency, and more important, the cooling purpose is taken care, right? It also takes care of optimal utilization of the equipment, the optimal maintenance which is required. Since it is at one place, you don't have to go after each and every building to do maintenance. You can do it. And once it is at one place, you can do proper maintenance. You have dedicated teams. Your reliability increases. So there are no chances of any discomfort because that system of that building is gone. Because they have multi-stage systems which are there. So even if one system knocks off, the other takes care of it. So that's the advantage of having systems at one place. Convenience. Now from the developer or the building manager's standpoint of view, it is attractive to be able to provide reliable comfort without worrying about managing the equipment. If I am a building owner, if I am worrying about my own air conditioning by putting my own system in the basement or terrace, I have to always think about its maintenance, its breakdown. Here, you don't have to do that. So that gives a huge convenience. You don't have to put a lot of efforts on labors, material to keep the system operation. That is taken care of, right? By this district cooling team, which will take care of everything to give you optimum comfort level, right? And you don't have to bother, you as a developer or building manager, you have to focus on your own business rather than thinking about this, worrying about this, right? So this is second aspects when it comes to end user. The third is flexibility. The pattern, timing of cooling requirements in building vary, right? Depending on the use, you will get that much cooling. So if the building is not working fully, you will only need that much water. So based on your flexible working, the need of your cooling is taken care. You don't have to unnecessarily pump more water even if your building doesn't require. That part is taken care of. The flexibility is important. When I come to an occupant, I have full flexibility, right? So each building can be as much as little cooling is needed whenever required without worrying about chiller cycling or efficiency. Fourth is reliability. As I said, since the system is at one place, the proper maintenance is taken care, the dedicated team are taken care, the redundancy part is taken care, You don't have to invest in maintenance of the system for your use. That is taken care. Only thing you have to think is you are getting the required chill water based on demand load. Right? There's one important point over here. One of the survey of existing DCs have shown the reliability of 99.9% as per International District Agency Association idea. So that's the reliability point of view. Sustainability. When you talk about putting systems everywhere, that takes care of the sustainability part. Here the building is only having chill water and your low side equipments, and they will give you the comfort at your requirement by maintaining the DC at one place. So district cooling is a combination where building efficiency measures can be significantly improved with respect to green building certification. This is one of the important aspects for end user. Then look at cost benefit. Now, cost benefit, one of the important aspects is you have got reduced installed capacity. You don't have to invest on equipments for cooling. That is taken care of by someone. That's the huge burden. First is getting capex in, and then to install and to put a lot of effort to get everything installed. Here you have to only look at the chilled water piping and only worry about the low side. Don't worry about high side. So huge amount of money can be saved. Optimize operation, right? With DC, equipment can be operated at the most efficient level. When you have everything at one place, you can get the best of the people to take care of the machines. You can carry out audits which are not that feasible for your own building. Here that is taken care by the DC team. One of the capital cost benefit, operating cost benefit of having district cooling. Chillers, condenser cooling equipments, you don't have to go about. Power required for those equipments, you don't have to worry about. Transformers, the electrical side, the DGs, the water treatment plant, don't have to look after. Don't have to be bothered about it, right? So all these things, construction costs, all these things can be saved. Operating costs, you don't have to install, have a separate operation team for high side. You don't have to look after schedule maintenance, periodic maintenance, refrigeration management, all these things, water quality management, all these things are taken care by the district cooling team. So both from the capital point of view and the operating point of view, district cooling is always useful. Let us look at the next stakeholder is environment. I called environment is another stakeholder because that's why we are existing, right? Energy efficiency. Now when I look at everything and when I take care of the building loads, I always get a lot of diversity. With the diversity can be as high as 30 to 40%. And a lot of technologies which can use, and we can make sure that the system at DC works at most optimal level to take care of the demand of the building. So this is first. Second, climate change. When I talk about climate change, again, there are various impacts on the climate because of the air conditioning system or the HVAC system, right? So district cooling can help extensively in mitigating the impact of new development on climate change through higher energy efficiency, and also leads to reduction in CO2 emission by 30 to 35%. Water saving. Every building need not have water supply for having your air conditioning system. So the data point over here, you can see how much water can be saved if we install centralized district cooling systems. Refrigerant saving. Refrigerant leaks will go on happening if you have multiple systems. The chances of leaks are higher. Here you have one system, hence there is a drastic reduction in the refrigerant leak and hence the saving of the refrigerant. These are all related to environment benefit. These are again a data point. Enormous potential for DCs, and this has been happening across the world. And when I talk about India, look at the data points for India. Investment potential of 35 billion. 6.6 million tons of annual CO2 emission reduction. Huge numbers. 785 gigawatt annual energy saving. Energy demand saving 6,100 megawatt. Look at water saving 78,850 million liter. Refrigerant saving 1,068 tons. These numbers are staggering numbers, and this is the numbers are for India, and the source is given in front of it. It's not numbers which I came with my own brain. These numbers are there with the right source. 10.5 billion in investment savings from infrastructure on power plant, city transformers, cables, water supply systems. So in all aspects, it ticks positively for India. This is very, very important, and that's the topic of the video. What is district cooling and what is the potential for India? These figures can give you huge amount of ideas why they are benefit. So summary of benefits for India, as I said, all aspects from the energy consumption, peak power demand, you can see the reduction. Water, life cycle of refrigerants, the reduced CO2 emissions, benefits for local grid, higher reliability, higher flexibility, and everything which is good for India to go for district cooling. One of the first district cooling in India is Gift City, which is in Gujarat. I think it's near Gandhinagar. It's a start, and there are huge opportunities in India to take it forward. So I hope I have given the synopsis of what is district cooling and what is the potential for district cooling in India. Hope you liked it. Please come back to me with your comments, your likes, your suggestions. Please subscribe my channel. Follow me on YouTube, Facebook, and ajazkazi.com. Thank you very much.